Last week, we talked about the product rule and the quotient rule. So the product rule gave us the ability to multiply two elementary functions together, and we could find the derivative of that product. Same thing with the quotient rule. If we took two elementary functions, or really any two functions that we knew the derivative of, we could find the derivative of their quotient. There's another really common way that we can combine two functions together called composition. We haven't talked a ton about it. I know you put some effort into it in Algebra 2, but again, I want to give us a little bit of a refresher of the way composition works. And then in later videos, we'll see how we're going to treat it in calculus. All right, so off to the document camera. So this might be the kind of problem that you're used to seeing, that if we've got two functions, f of x and g of x, we could think about saying, what is f of g of x? So what we do is we always start with the thing inside the parentheses. So g of x is equal to x cubed. So that is equal to x cubed, f of x cubed, which means that we look at the rule for x, f of x, and wherever we see an x, we're going to replace what our input is. So here, instead of x, we're going to replace it with x cubed. And so f of g of x is equal to 2x minus 3. We could do the same thing in the opposite order. First, we think about what f is, and then we take g applied to the output of f. So the output of f becomes the input of g. And the output of f is 2x minus 3. And again, the rule for g is that it cubes the input. So here the input is 2x minus 3. So we're going to take 2x minus 3 and we're going to cube it. So when we do this, when we combine these two functions like this, we get another function. And the technical notation for this is we're going to have f and g, and we're going to have a little tiny circle in the middle of it. So don't confuse that for an O. It's kind of like a degree symbol, except it's in the middle of the line instead of the top of the line. And here we've got G and then F. And I think the kind of thing that you normally did in Algebra 2 is that you would compute this both ways and then see, it makes a difference whether you compute G and then the output of G is equal to the input of F, or if you take the output of F and feed that in as the input to G. So this function composition is not commutative, is the official math vocabulary for this concept. But this should remind you, hopefully, of the way that function composition works. And what we're going to be able to do is now, just like we have the product rule and the quotient rule, we're going to have a new thing called the chain rule, which says that if we have two functions and we know their derivatives, we can find the derivative of their composition, which is like chaining them together, which is why it's called the chain rule. And so first thing we're going to do is we'll do one more quick introduction thing, and then we'll start talking about what the chain rule is.